So a quick video about a silly experiment, how to drive a MOT micro oven transformer through its low voltage winding for the filament of the magnetron. In fact, I have here this MOT. This is the smallest MOT that I have. I characterized it to be 200 watts with the old style of classification of transformers, 700 volts amps, but it's really small. And I'm powering it through its low voltage winding, just 3 volts winding, through my multipurpose transformer here at just 2 volts from this winding, 12 volts minus 10, 2 volts SC. Okay, let's read its output voltage on the high voltage winding here. That was originally 2 kilovolts at 230 volts SC on the primary. With a multimeter, but there's a catch. I have here this tool that I made. There is an alligator and 9 resistors insulated this way. 9 resistors of 10 megohms each, so it's 90 megs that in series with the 10 megs of the impedance of the multimeter will make a voltage divider that will be 10 to 1. So when this makes 2 kilovolts, the multimeter will show 200 volts. I also have here a current clamp meter that will read the current on the filament winding here. That will be fairly high anyways. Let's turn it on. And we have a voltage of 800, kinda 800 volts, and a current on the filament winding of more than 8 amps. This thing reads an ampere less, so it's like almost 10 amps. Another way to read the output voltage on the high voltage secondary is to read instead the voltage on the original primary, that is free, but connected to my multimeter, a regular IC voltage reading. And the high voltage secondary will make like 9 times the voltage you see on the primary. So let's turn it on again. And we have in fact a voltage of like 82 volts SC on the primary. And again a current of almost 10 amps. Anyways, I tried with a higher voltage out of this transformer, my multipurpose transformer, but it makes an insane amount of current. Let's turn it off. Up to like more than 20 amps, so this system is extremely inefficient. Okay, now let's read the output current, short circuit current of the secondary voltage secondary, again with the multimeter in current reading here. So the secondary will be shorted. Let's turn this on, and we have a current of 26 milliamperes and current on the primary of almost 15 amps. So now let's try a load, whatever load, a fluorescent tube that will be struck on the output of the transformer on the voltage secondary. Let's turn this on, and it goes on magically, but it flickers, especially under the naked eye because it's synced with the camera of the phone. And it's not steady. And the reason why it flickers is probably because when the tube strikes, it makes a short on the secondary of the transformer, and this makes the magnetic flux on the core bounce, or kinda. The wires are hot, by the way. This bouncing of the magnetic flux in the core makes it ready or not for the subsequent oscillation of mains to strike again the tube or not, and it's kinda random at the end. Anyways, we had 12 amps, kinda. Okay, now let's see some arcs. Let's turn this on. Again, kinda 10 amps of consumption. This is the ground wire. The MOT is earthed anyways. Let's see. Puny sparks. Okay, the idea was also, let's turn this off, was also to make this thing safe, but it makes like 25 milliamperes in short circuit, and probably the original primary here, 230 volts primary, makes much more current, so it's also not much safe there. But no, I don't feel safe to touch this thing anyways. Again, anyways, thanks for watching my video, and bye!